Welcome you all. Once again, a warm welcome to you all who's present here to listen my video. So my video is on the topic hydraulics and pneumatics. So this is a typical subject which is being handled in 17 regulation in university regulations. This subject is purely based on how a system works. That is how a system gets power to perform a work. Okay, the power which is being produced is due to hydraulics and pneumatics. That is due to a fluid. The fluid may be a liquid or it may be a gas. So depending on this fluids, it performs an operation. The operation which is being performed is also evaluated, and this evaluation gives the best results that these fluids perform a better operation when it is being implemented. Now we are going to see these topics in detail. Let's get into the session. Nowadays, we know that countries as well as states development is based on how a state is preserving power consumption, how it is going to utilize the power. Power in the sense the technology is fully dependent on how to generate power, how to distribute power, and how to utilize the power. So these three things is essential for a country as well as for a state to adopt. So if these three things have been followed in a proper manner, then we can emerge as a good nation. So for this development, we need a complete power packed setup as well as power packed component for each and every operations to perform. Operations in the sense typically a working component. It may be in industry, it may be in aircraft missions, or it may be in the manufacturing process doing operations. So whatever maybe it is, but to perform some particular task, okay, what is the power we need to perform that? So that power it fully depends upon these topics, hydraulics and pneumatics. So now this is a big chapter where we are going to learn a lot about the power which you are going to get from which you are going to utilize. So now in our topic we are going to learn the properties of a fluid. Okay. So before we are going to see the properties, we must know how a system is working efficiently by the it is mainly based on the output input which we give. So depending upon the input which we give, the output is obtained. So the input is this hydraulics and pneumatics. That is the fluids, something but oil or air. So the oil or air which we are giving as an input performs a specific task, and that task is completed very fast in accurate manner. So which will provide a betterment of that doings. So this is the thing we have to know first. So now how this power is achieved. So to achieve this power, what are the things we have to adopt? So what is the property the fluid has to adopt? What is important properties it must have? So likewise, we're going to see the properties of this of fluid in general. So and then after that, we're going to learn what are the good properties an hydraulic fluid must possess. So these things we are going to see in this video. So now we can see a slide. So in this, we are having some essential properties. We are having some 6 essential properties which is very basic to us, and we have to know and we have to keep an eye on it because all fluids possesses this six properties always. So in this six properties, first we are going to see about the density. What is density? Density is nothing but it's mass per volume. Okay. So how in the confined volume, that is in confined space, what is the mass it is occupying in that volume, in that space? For example, gas, liquid, and solid. These three have a confined volume and a confined mass. So for gases, we'll be having the density very less. For a liquid, we'll be having somewhat dense, and for a solid, we'll be having a complete power packed, um, closely packed density. So depending upon the mode of uh, mode of phase, it changes. Okay, so this is density. So a fluid must has a confined and defined mass and volume, so that it can occupy in a confined space when it is being implemented. So one thing you have to keep in the mind, fluid, when I am telling fluid, is something but it's a combination of liquid and as well as gases. Liquid, we are categorizing into two things. One is water as well as oil. And then in the gases, we are going for air. Air or any inert gases or atmospheric gases which is involving in this atmosphere. So it comes under that. So the next property which we are seeing is specific weight. Specific weight. So specific weight in the sense, liquids must have a specific weight. That is, it must have a confined mass, so that it can be poured, or it can be transferred, or it can be converted from one place to another. So it must have a specific weight, which is carry out, which is very useful in forcing that to go from one place to another. So likewise, we are having specific gravity. Okay, specific gravity is nothing but this relative density, that is the ratio of mass of a fluid to the mass of the standard fluid. So every fluid possesses its own gravity. So in this gravity, this is compared with the standard fluid mass, that is the whole weight of the fluid. So the whole weight is compared with the standard weight of the fluid. So this is specific gravity. So next comes the viscosity. Okay, so which is a very important term you must know. You must be learning in this chapter. Viscosity. So viscosity is the measure of the ability of a fluid to flow. It's the ability of a fluid to flow. So how freely the fluid flows, or how um, limitedly a fluid flows. How the flow is in a pipeline, or in any flow pattern. So viscosity we'll be learning briefly in the next slides. Okay, so next we can go for specific volume. Okay, a fluid, when you are going for an hydraulic fluid, that is going for an uh, liquid. So a liquid has a confined space, a confined volume. So where it has to be it has to be deposited. So there is a specific volume a liquid has to occupy. So likewise, the air also. The air also should occupy a specific confined occupied space. So that space is nothing but specific volume. So amount of volume, space it is occupying. It may be a gas, it may be a air. So it may be a oil. Okay. Then vapor pressure. So a fluid, when you're going for a liquid, when it is attaining some temperature, means there's a chance of getting into the vapor state. So the change of phases takes place when there is certain amount temperature reaches. So that temperature is being calculated, and then accordingly the fluid is being used to make power production. And now we're going to learn about another important properties of fluids. So last slide we have seen some six properties, which is a basic property of fluid should process. Now we're going to see the important properties, the essential, very essential properties a fluid must possess. Okay, so in that we're going to see the first one is cohesion and adhesion. Cohesion and adhesion. So cohesion means nothing but sticking together, otherwise sticking together of particles of same substances. Sticking together of particles of same substances. Okay, for example, uh, a water is attracted to a water. Whereas a simple water drop is being attracted by another water drop. So both get mingled. It gets sticked. Okay, so it's an example for cohesion. It is, see the slide, water sticking to water. So this is a water droplet. This is another water droplet. This both gets combined. So that property is called as cohesion. For example, if you take a needle, so in that needle, if you drop a water droplet, the droplet will be hanging at the tip of the pin. So at the tip of the pin, it will be hanging. So what does that means? It is sticking to the pin. Okay. So this is an example for cohesion. So addition, then and the next thing is addition. Addition means sticking together of particles of distant different substances. Different substances. So that is called addition. Okay. Here water is attracted to other substances. Water is attracted to other substances. It is called addition. Okay. So if you see the image, we are having one water droplet and another one unknown component. It may be anything. So water gets attracted to this component or any other substances. This is the next important property, cohesion and adhesion. So next comes the property surface tension and capillarity. Surface tension and capillarity. Surface tension is nothing but a liquid being unable to expand freely. A liquid being unable to expand freely. So you can see the image. We are having a cup of water in which we are dropping a pin, gem clip or a pin. We are dropping it. If we when we drop this pin occupies some space and it dislocates the water present in that area. When it's dislocating, this water surfaces cannot expand freely. It has some tension in it. So if you, in the same wise, if you drop a needle in a vertical position, the needle goes in very smoothly. So you can understand the difference between both when you are dropping it horizontally as well as when you are dropping vertically. So there is a force which is being restricted. There is a surface which restricts the uh, penetration of this spring. So that surface is called is having surface tension. Okay, so next property you can see capillarity. So when you are dropping a ball in a water, okay, when you're dropping a ball in the water, due to surface tension, it gets slowly inside the water and also due to gravity. But at that time, uh, this curve indicates the capillarity of the fluid. So how much capillarity, that how much fluid can occupy. So that space is called capillarity. So you can see an image here. So there we are represented the capillarity rise here. So capillarity can be divided into two things. One is rise, one is low, lowering. So both can be explained here in this image. So here is capillarity rise is involved here. Okay. In the next slide, we're going to see what is cavitation. So this is also important property. Cavitation is a phenomena in which rapid changes of pressure in a liquid leads to formation of small water vapor filled cavities in places where the pressure is relatively low. That is, there is a surface. In the surface, continuous water is this is high pressure fluid is being this water is being spreaded. If this high pressure water is being spreaded, there is a vapor bubble is formed. You can see the image first. As a vapor bubble is formed. So this vapor bubbles goes on continuing means you can see a vapor bubble collapse is seen in the next image. So if the pressure goes on increasing, you can see a collapse in this vapor bubble. So again further the pressure increase goes on increasing, the bubble collapse to a greater extent. Bubble collapse to a greater extent where the size of the bubble gets reduced, but the depth of the penetration gets increased. So again and again, if the pressure goes on increasing, means there is a subsonic fluid microjet is ejected. That is, the depth of penetration goes very deep, and then it comes out with a very high pressure, and that pressure is exerted on the surface where the fluid is being pressurized and poured. So here in this place, there is a lot of pressure involved. So cavitation will makes these parts to get damaged. Okay, so I'll show an image where the cavitation plays a vital role. See, this looks like a impeller. It's a turbine impeller or a turbine blade, which is three axially curved. So in here we can see the cavitation part. So this is due to continuous and due to high speed jet. So the high speed fluid goes on felt in the same place. These markings have been formed. So these markings have been called as cavitation. So it can damage the whole blade system and it will be easily damaged. So this is one of the important property cavitation. So next we are going to see what is compressibility. So compressibility is the measure of the change in volume of a substance that undergoes when a pressure is being exerted on the liquid. So compressibility you can see. Liquids we cannot liquids are incompressible. We can't compress it. If we compress means it will be splashing out. But gases and airs are compressible. So liquids are generally considered to be incompressible. So if you see this diagram, we are applying a force on the piston. The piston gets inside this and compresses this fluid inside. So when it is compressing, its volume decreases and density increases. You can see this. If you apply a force, it gets down and then volume decreases. The volume decreases, and the density inside this liquid gets increases. So when we are applying a force, the force will make the liquid to be concentrated in a particular place where the density gets increased. So you can see the third image. Here we are the applied force is being removed. So the force is being removed here. When you remove this force, there is a volume gets increases. See, you can see the blue color part. So the volume gets increases, whereas density decreases because when the force gets exerted, here the filling of this liquid, which is not dense, so automatically density decreases. Okay, so depending upon the force, the volume varies and density varies. So this is called compressibility. Okay, so next thing you're going to see is cloud point and pour point. Okay, so this cloud point and pour point is something at the temperature at which the dissolved solids begin to crystalline and become noticeable when liquids are chilled under specific conditions. So cloud point is nothing but in a fluid, the fluid has to be in its liquid state only. So if the states are changing means there is no use of using that fluid. So we have to be very keen while using this fluids. For example, in Switzerland like areas, when we're going for this fluids, for example, we are going for an oil for a water. for production of power. So that time these fluids may get freezed. So if it gets freezed means the system going to get collapsed. So at that time, to avoid it freezing, we are going for a point called as cloud point. So likewise, pour point is also there. So pour point is also like that. The 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 fluid which we are using must be in the fluid state only. If it is exceeding the lake, it's going for a recrystallization temperature, that is a crystalline structure, it goes for a solid state, and then if it goes this side, it goes to a gaseous state. So there must be no change of phase. If there's a change of phase means there is no use of using the fluid in the system. So that point is called pour point. So the initially how we pour the liquid must be in the same state. It is the same phase. The phases must not get changed when there is any temperature change or pressure change or anything else. The parameters are many parameters that can affect that can affect the fluid. So we must be very keen in this regarding this. This defined as the minimum temperature in which the oil has the ability to pour down from a beaker. In a flowing from a beaker, it has the ability to pour when it is being poured. So we have to maintain the temperature of this fluids properly. So this is the thing they are telling in this chapter, in this topic. Next thing we're going to see is the properties of good hydraulic fluid. Good hydraulic fluid. Now we are going to see only about the hydraulic fluids. We're not going for pneumatic. So we're going only for hydraulic fluids. This the properties which a fluid has to possess. So we are having some 11 properties in which the first property is the basic property viscosity. So we have seen viscosity. For a good hydraulic fluid, it is a good hydraulic oil must possess optimum viscosity only. So if there is low viscosity, we could not seal sufficient we cannot seal sufficiently. That is which leads to leakages. We can't seal a container or we can't seal a box properly. So there is a leakage when the fluid is having low viscosity. So similarly, when the fluid is having high viscosity, the fluid will be difficult to pump. You can't be able to pump the fluid freely. So there is some difficulties in pumping the fluid in case of high viscosity. So you must maintain an optimum viscosity. So as well as we can increase and decrease the viscosity depending upon the conditions we are using and applying. So this is about viscosity. So next comes the compressibility. So compressibility is you know that liquids are incompressible. So a low compressibility must be maintained in case of a good hydraulic fluid. Okay, so if we increase the compressibility means the pressure and temperature gets increased, as well as the system gets collapsed. So this is an important property of it. So next comes the wear resistance. So wear resistance tells that a fluid a fluid must possess. So wear resistance possesses that the fluid, for example, the oil which we are using must not affect the components in the system. Okay. In case any wear or any corrosion happens, means the system is going to get collapsed. So we have to use a fluid which must not possess wear. So we must be very keen in this regarding. So wear resistance avoiding parts must be used. Fluids must be used in these cases. Okay. The next comes the oxidation stability. Oxidation stability. That is to maintain the temperature in this regard, anti-wear agents are being added here. Okay, so if that is added, the level of thermal stability is maintained. The temperature is maintained here. So, for example, the oil flows in a tube. So, if the oil goes on flowing, means there is a chance of the temperature gets increased. So, when temperature gets increased, means the oil also gets heated, and there is some impurities formed, as well as the hoses get damaged. So, due to this damage, there is a leakage problem occurring. So, we must use